Nice. So analysis of variance, or ANOVA for short, enables us to compare more than two samples. For example, in the most recent video at the end, we had 3 islands that we could make a comparison across. And so the ANOVA allows us to make that comparison in a single statistical test. To apply the ANOVA, we must make 3 assumptions. So first of all, they must be independent samples, so not paired samples, but independent. They must be normally distributed populations, so we assume that the underlying population is normally distributed, and we assume something called homoscedasticity, which means that the population standard deviations are equal. So while the ANOVA formula is not especially complicated under the hood, you can dig into it by clicking this link. The ANOVA might be the least widely applicable topic within this subject of my Machine Learning Foundation series, so in the interest of time, we'll skip straight to the Python code. So remember, we want to compare these 3 distributions of our female Adelie penguins from the 3 different islands, Torgerson, Biscoe, and Dream. And so we can do that using this one-way f-test. And so this f-test, it does an ANOVA, and it provides us with an f statistic. So we can pass in our multiple samples. In this case, we have 3 of them in the T, B, and D vectors that we created earlier in the notebook. And so we can simply pass those into this method, and we get a f statistic of 0.22, or 0.23, I guess. And that p-value is nowhere near significant, so it's absolutely nowhere close to being less than 0.05. It's 0.8. And so overall, across the 3 islands, there is no statistically significant difference by island. Now, that isn't to say that you couldn't separately do a t-test comparing 2 specific islands, but overall, island does not cause the female weight to vary significantly. Nice, so all of this about t-tests, confidence intervals, and the ANOVA, it allows us to compare the means of distributions. But there's another really kind of interesting comparison between two distributions. So if we have paired samples, like we do in a paired sample t-test, we might also be interested in whether the relationship between those paired vectors is a statistically significant correlation. So that's coming up next.